Sum of geometric progression. Consider the sum Sn of the first n terms of a GP. So we say here, the first n terms of the geometric progression will be A plus A times R plus AR squared plus AR cubed right up to AR n minus 1. Now, if we multiply this by R, so that we'll have R times the sum of the first n terms, we shall have AR plus AR squared plus AR cubed plus AR to the fourth right up to AR to the n. Call this equation 1, call this equation 2. Now, if I subtract equation 1 from equation 2, here I have the sum of the first n terms minus the product between R and the sum of the first n terms. This will give me, what do I say? These terms will cancel. At the end, this one will also cancel out somewhere there. At the end, I'll have A minus 1. A times R to the n. Let me factorize this. This will be Sn 1 minus R is equals to a factor of 1 minus 1 R to the n. I want to make Sn our subject. Sn, the sum of the first n terms will be a factor of 1 minus R to the n all over 1 minus R. So we can state this formula in two ways. Sn, the sum of the first n terms will be a factor of 1 minus R to the n, all divided by 1 minus R when the absolute value of R is less than 1. That is when we are dealing with common ratios that are fractions. In case our common ratio, the absolute value of our common ratio is greater than 1, we state the formula as sum of the first n terms will be a factor of R to the n minus 1 divided by R minus 1. Given this sequence here, we find here that the values are reducing. Our common difference R here will be T2 all over T1, which is 9 all over 27, gives us 1/3. Our R here is 1/3. Let's look for the sum of the first 10 terms. We use the formula summation of first n terms will be a factor of 1 minus R to the n all over 1 minus R. So, sum of the first 10 terms will be as A 27 factor of 1 minus 1/3 to the 10th all over 1 minus 1/3. So here we need a calculator. This will be 1 minus 0.000016935 divided by 0.66667. This will give us 27 times 0. Divided by 0.66667. So punching this on the calculator will give us sum of the first 10 terms in that sequence will be equal to 40.6 49899. So we find that in this sequence, the values become progressively very small. We can then talk of the sum to the infinity, that is, sum to infinity. What do we know? We know that sum of the first n terms here is a factor of 1 minus r to the n all over 1 minus r. But what do we see? As we approach infinity, r to the n becomes approximately equal to 0. So here we say that Sn will be equals to, this is 0, 1 minus 0, which is equal to 1. So this will become Sn is equals to a factor of 1 minus 0 all over 1 minus r. So we can state our sum to the infinity will be equal to a all over 1 minus r. So if we come back to this our sequence here, and we have to look for the sum to the infinity, this will be equals to, what is a? Our a there is 27 divided by 1 minus 1/3. This is equals to 27 divided by 2 all over 3. Sum to infinity is equals to 27 times 3 all over 2, which will give us 40.5. The first term of a GP is 20 and the common ratio is 6. Find the sum of the first 6 terms. The first term A is equals to 20. Our common ratio is 6. What do we know? We know that the sum of the first n terms of a geometric progression is given by the formula a factor of r to the n minus 1 all over r minus 1. We know here that the absolute value for r is greater than 1. That's why we are using this formula. So here, sum of the first 6 terms will be equals to 20 factor of 6 to the 6 minus 1 all over 6 minus 1. Sum of the first 6 terms will be equals to 20 factor of 46,656 minus 1 all over 5. This will be equal to, so this will give us 4 times 46,655. Sum of the first 6 terms will be equals to 186,620. So now this is our first term here, u1. This is the second term, u2. Third term, fourth term, fifth term, sixth term. Now let's work out a sequence for the sum of the terms. Let's call this S1. What is S1? S1 is just U1, which is 2. S2 will be U1 plus U2, which gives me 6. S3 will be U1 plus U2 plus U3, which gives me 14. So S4 is 14 plus 16, which is 30. S5 is 32 plus 30, which is 62. S6 is 64 plus 62, which gives 126. And this sequence can continue. So now, what do we see here? I see here that if I subtract S2 minus S1, what will it give me? This is 6 minus 2, which gives us 4. And this 4 corresponds to U2. So S2 minus S1 is equals to U2. Let's take another one and try. If I use S4 minus S3, this is 30 minus 14, which is equal to 16. And this 16 is U4. So U4 is equal to 16. What does that tell us? It means that U4 is equal to S4 minus S3. We need to make a general statement relating the sum of the terms to the value of the terms. What do we say? We'll say U to the n is equals to Sn, the sum of the first n terms, minus the sum of the n terms minus 1. We can equally quote the formula as t to the n is equals to Sn minus sum of the n terms minus 1. Let's now use this formula to solve one or two problems. Given that the sum of the first n terms of a certain series is Sn is equals to n factor of 2n plus 3, find the fifth term. B, find A, the fifth term, B, the sum of the first 10 terms. So, we are looking for the fifth term, T5. It's what we don't know. Now, what is S5? S5 will be equals to 5 factor of 2 times 5 plus 3. Do that which is in brackets first. This is 10 plus 3. This is 5 factor of 13. This is 65. So, our S5 is equals to 65. Now let's get S4. S4 is equals to 4 factor of 2 times 4 plus 3. S4 is equals to 4 factor of 8 plus 3. S4 is equals to 4 factor of 11. S4 is equals to 44. Now, how do we get T5? T5 is equals to S5 minus S4. The fifth term is equals to 65 minus 44. Fifth term is equals to 21. The second part, we have to look for the sum of the first 10 terms. S10 here will be equal to, apply our general formula, 10 factor of 2 times 10 plus 3. S10 is equals to 10 factor of 20 plus 3. S10 is equals to 10 factor of 23. Sum of the first 10 terms will be equals to 230. The sum Sn of the first n terms of a sequence of real numbers is given by Sn. Find the first term and the 10th term. So, what do we see here? We see that our S1 is equals to T1. Let's get S1. S1 is equals to 1 factor of 1 plus 5. S1 is equals to 1 factor of 6. S1 is equals to 6. How do we get T10? So that T10 is equals to S10 minus S9. What is S10? S10 will be equal to 10 factor of 10 plus 5. This is 10 factor of 15. S10 is equals to 150. Now let me get S9. Solve the first 9 terms. That will be S9 is equals to 9, factor of 9 plus 5. S9 is equals to 9, factor of 14. S9 is equals to 126. I come back to this statement. T10 is equals to S10 minus S9. T10 is equals to 150 minus 126. T10 is equals to 24.